Hello everybody, my name is Mr. Sheldon, and today we're going to be talking about equations with variables on both sides. So started off here at the top, it says, Keisha modeled the equation x minus 3 equals negative 2x plus 5 at the right. So here is her model of it using algebra tiles. So it's asking, what do you notice about the equation? Well, something that we haven't worked with yet, and something that, like you could see in the title, what we're going to work with is variables on both sides. This has an x on the left side of the equal sign and x's on the right side. Up until now, we've only worked when x's are on one side. Now we're going to work on problems that have variables on both sides. So that first question says, what do you notice about the equation? We notice that there are variables on both sides. Now it asks, how can Keisha collect the variables on one side of the equation? Well, the variables themselves, like whenever we collect like terms, what we can do whenever we move our constants over, these ones, is we can subtract or add to get them to the other side, right? So if I were to move the constants over to one side, I would just add 1, 2, 3 to this side to get it over here to the left, right? Well, we can do the exact same thing with our variables. And so what we can do here is we can add two x variables right here. And whenever we add to one side, we always have to add to the other. So we can add two x variables as well. So going back, it says, how can Keisha collect the variables on one side? We can add 2x to each side. And what that does is this cancels out, leaving us with only variables on one side. That's what we're going to try and do here whenever we solve with variables, is we want to get the variables on one side and the constants on the other. Whatever variable we're solving for needs to be on one side and everything else needs to be on the other side. So now the third question asks, how can Keisha collect the constants on one side of the equation? Well, we already talked about that. If we have our variables now on the left side, we need to get everything else on the right side. So what can we do? We can add 3 ones, like I said earlier, to this side, and anything we do on one side of the equal sign, we have to do to the other side, remember? So we can add 3 ones over here. And so what happens? Well, these cancel out, these cancel out, and these cancel out, leaving us with our variables on one side and our constants on the other. So just to show you guys, this would be equal to 3x equals 1, 2, 3, 4, 5, 6, 7, 8. 3x equals 8. And so just coming back to here, how can Keisha collect the constants? We can add 3 to each side. So that kind of gives you the overview of how we're going to approach these problems. Going off of our notes and what we need to look at our steps to solve. First off, what we need to do is distribute and or combine like terms if necessary. So just like we worked on at the very beginning of our school year, we've been working on collecting those like terms. Anytime you see constants on one side and or variables on one side, if there's say 3x plus 5x, you can put those x's together, right? So what we can do now then after that is we then collect variables on one side of the equal sign, like what I did up here first. I got rid of the variables on the right side and I had to move them to the left. Then what you want to do is you want to collect the constants on the other side of the equal sign, like what I did here where I got rid of these ones, right? And I moved them over. And then our last step is just to solve the equation. So something that Miss Blackwell wanted me to go over with you guys is what we like to say, don't call me at midnight. And what this stands for is D means to distribute. All right, this is our step. So D would be to distribute. C, we then combine our like terms. This M stands for move our variables. So we're going to move our variables over to one side. And then our A is to add or subtract our constants to get those to one side as well. And then our last step here is to multiply or divide the coefficients. So going back up here to this, the only thing I have to do left with this question is just to divide each side by 3, giving us what our x by itself equals. All right. So moving on to the first question, what we're going to do here is we're going to do number 1. So what would we do first? Well, looking at it, do I have to distribute anything? No, right? There isn't any parentheses or anything I need to distribute. So our next one, our C, so don't call me at midnight, our C is our to combine like terms. Do I need to do anything like that here? No, because on the left side, there's an 11x minus 8, so you can't combine any of those. And on the right side, there's negative 7x plus 64, and I can't combine any of those, so I don't have to do any of that. Our next step is to move the variables. So what I'm going to do, because I don't like these negative signs, I would like to add 7x to both sides. All right. Doing that, what is 11 plus 8? Or sorry, 11 plus 7, sorry. That is 18. X minus 8 equals, these cancel out, leaving me with just 64 on this side. And then our next step is to add or subtract the constants, right? That A. So to add, we can move this constant over to the other side, because remember, all we need is the variable by itself on this side. So we'll add 8 to each side. And just another reminder, anytime you do anything to one side of an equal sign, you have to do it to the other. So that's why I'm adding 8 to both sides. So by doing that, this 18x stays the same. These cancel out, leaving us with 64 plus 8. What is that? 72. And then our last step is to get this x by itself. So we're going to divide both sides by 18 to get that x by itself. And so let me pull out a calculator real quick so you guys can see. 72 divided by 18, that equals 4. And we know that 18 divided by 18, these just cancel out, leaving us with x equals 4. And that would be our answer. Now to check this, what you can do is you can plug in 4 for any x in our original equation up here. So if I rewrite it, 11x minus 8 equals negative 7x plus 64. We then have to plug in this 4 for all of our x's. So I'm going to put 11 times 4 minus 8 equals negative 7 times 4 plus 64. Sorry, it's a little off. So what's 11 times 4? Well, we get 44 minus 8 on this side. What is negative 7 times 4? That's going to be a negative 28. Plus 64 on this side. And so now what's 44 minus 8? That gives us 36. And then on this side, we have, I can do 64 minus 28. And that also gives me 36. So because I have the same number on both sides of the equal sign, that checks out. And both of the equations are equal whenever x equals 4. So now moving on to number 2. So what do we do first? Well, let's look at up here. Don't call me after midnight. D is distribute. Do I need to distribute? Yes, right here, right? You put that 5 into both of them. So if I rewrite this side, it's negative 2x plus 9 equals, what's 5 times 2x? It's going to be 10x. And then 5 times negative 3, that will be negative 15. So then our next, we need to combine any like terms, do we? No, not for this question, because on both sides, we don't need to, because there aren't like terms. This isn't variable and a constant, that's a variable and a constant. Next, we need to move the variables. So because this has a positive number and this is a negative number, I like to get rid of that negative sign. So I'm going to add 2x to both sides, leaving us with, that's going to cancel out. 9 equals, sorry, that's supposed to be adding. What is 10 plus 2? That's 12x minus 15. All right, then we need to add or subtract the constants and get those to the other side. So I'm going to add 15 to get those constants on the other side of that equal sign. That will leave us with 24 equals 12x. And the last thing we need to do is multiply or divide to get x by itself. Well, in order to do that, I will divide this by 12 and this by 12. And what is our x equal to? What's 24 divided by 12? And that is 2. And so now we found our x. So we found our answer. Now we can check it if we plug in 2 everywhere. So what I'm going to do here is, because I've already distributed here, I'm just going to plug in the x for this line right here where I've already distributed. You can do it in this one too, but it's just going to be more work. If you've already distributed, we know that this section equals this. So what I'm going to do here is I'm going to do negative 2 times 2 plus 9. So that's that left side. And then the right side is 10 times 2 minus 15. And so what is negative 2 times 2? Well, that's going to be a negative 4 plus 9. And what is 9 minus 4? That's going to be 5. And then what is 10 times 2? Well, that's 20 minus 15. What is your 20 minus 15? That is 5 also. And because both sides equal 5, we know that that is correct. And so that's how you would check your work. So now moving to our last one. Let me move that out of the way. We are going to work on number 3. We're going to hit more during class. We'll do number 4, number 5, but I'm going to just hit number 3 for the last one. So first off, what's our first step? It is to distribute, right? So do we need to distribute here? Yes, we need to distribute in 2 places. On that left side, we need to distribute that 5. We also have this 1/5 over here that we need to distribute too, and put those in because it's outside of the parentheses. So on this left side, we have 5 times k. Well, that gives us 5k. We also have 5 times 14. Well, what is 5 times 14? If you pull out your calculator, 5 times 14, that gives us 70. All right. And then on this right side, what is 1/5 of 20k? Well, for those who don't know, what you can do here, taking 1/5 of something is the same way of saying you can divide this by 5. So what I'm going to do is I'm going to take 20 divided by 5, and that gives us 4k. All right. And then what is 1/5 of negative 80? Well, I can do the same thing. I can take negative 80 and divide that by 5 as well, and that will give us a negative 16. All right. And so now what's our next step that we need to do? We need to combine like terms. Do we need to do that in here? No, just like the other 2 questions, you have a variable and a constant, a variable and a constant. You can't combine anything on other sides of the equal sign. So we're done with that one. Next would be to move the variables. Well, I see that both are positive this time, so I don't have to get rid of any negative signs, but I see that this 4k is smaller than 5k. So what I'm going to do here is I'm going to take a negative 4k and get rid of that on that side. And do the same thing over here. which will give me k plus 70 equals, those cancel out, negative 16. And then the last thing that I need, or the next thing that I have to do, I'm sorry, is add or subtract the constants. And what we need to do here is, like I've said before, get this variable by itself on this left side. And so what can we do next is we can subtract 70 from this side, right? To get that 70 over onto the right side, leaving us with k over here, because that cancels out, equals, and then what is negative 16 minus 70? That's going to leave us with negative 86. All right, and here's our answer. And again, you can go and check like we did on this side, but I'm going to leave that to you. And we will practice more of this in class. Thank you guys.